Page 13 of your notes has the following diagram. It has a circle, okay, and in this circle you'll see, what does it say? We have the 4 quadrants, as you're all very aware of. And then it has a point here, alright, and what that point says is cos A and sine A. Is that okay with you guys? Alright, and it has this written down as, sorry, use a different colour. It has this written down as angle A. So A is from here to here. Okay? Now there's something else you need to know about this circle. It's known as the unit circle. What does a unit circle mean? Has a radius of 1. Okay? So, for argument's sake, it's actually missing the number 1 here. See 1 sine A and 1 sine B? Oh, sorry, 1 sine A and 1 cos A? There. Now if this wasn't the unit circle, and for argument's sake that was the length 3, what would you think the points would be then? 3 cos A and 3 sine A. Now for argument's sake, okay, you can do something like this, alright? Do you remember we did a 3, 4, 5 triangle earlier? Remember we said that's 5, and for argument's sake that's 4 and that's 3. Okay? Could somebody find me the angle A? You can cos inverse, tan inverse or sine inverse. Which one do you want to do? Your choice. Alright, well sine inverse 4 over 5. If you aren't sure, somebody else can tan inverse 4 over 3. And somebody else isn't sure, they can cos inverse 3 over 5. You're essentially going to find an angle, aren't you? So what angle would that be? Who got 53.13? Right. Now, we all agreed that angle A in this case is 53.13. Everybody cool with that? Alright. Next thing I'm going to ask you is this. Okay. What's the radius of this circle? Is everybody happy the radius is 5? So would everybody agree that this is 5 cos 53.13 and 5 sine 53.13? Would everybody be happy that's the coordinates? Now, from junior cert, from first year geometry, what point is 3 to the right and 4 in the air? What point is 3 to the right and 4 in the air? What? Exactly. Now, here's what I want. Half the class put in 5 cos 53.13. The other half the class put in 5 sine 53.13. What answer are you expecting? Expecting 3, 4, aren't you? Do you get 3, 4? What? Yeah, because you did the blue one. And the lads who did the yellow one got 3. So, this is what's known as polar coordinates. Is everybody cool with that? Polar coordinates are the way we can use sine and cos to say any point we want, using any angle we want. So, for argument's sake, if I say this is a radius of 7 and an angle of 60, can you guys tell me what the coordinates are to 2 decimal places? How would you do that? Look at your notes on page 13. Which one comes first? Cos or sine? So you're going to do 7 cos 60, and then you're going to do? Right, would you tell me what the 2 things are when you get them?
7 over 2 for cos.
Sorry?
7 over 2 for cos.
7 over 2. So 3.5.
Yeah.
And the other one?
7 over 3 over 2.
Which is just in decimals.
6.06.
So 6.1. So that would be that coordinate. So any coordinate can be explained in polar coordinates, which are these ones here, or they can also be explained in Cartesian coordinates, which are these guys here, or regular coordinates. All right. Now, So what we're going to do the cosine rule is the following, right? Now you do have to learn this off. You have to learn the diagram off by heart, otherwise you're goosed. All right. So the deal here is you're using angle A. Angle A is the one you're going to use. Okay, and just have it learnt off. It's obtuse, right? Here we go. Okay, here you go. A triangle of my choosing, but angle A is the obtuse one, alright? So, and you might go. Now, what I'm going to do next is I'm going to do an example where I mix up all the letters are completely mixed up on me. Okay, just in case. Imagine you forgot how to do the diagram. So I'm going to show you a different way where everything's completely out of order, but you can still work your way over it. Okay. And we draw our diagram like so, right? This is the origin, alright, and this is going to be A, and that's vertex A. So what does that mean about this length here? Small a, okay, and this is going to be vertex B, okay, and your vertex C. Now what's that mean about this length here? Small b, is that okay? And what about this length here? What? Small c. Alright. Construct a circle of radius c. Is that alright? So, construct a circle of radius, radius b. Now, you're probably wondering why I'm choosing radius b. Alright? The reason being is the answer's on page 13. Okay? Because I want my coordinates to be on the circle using angle A. Okay, I want to use angle A to find my coordinates, okay? Is that alright with you guys? Now, so here's what we're going to do. Construct a circle of radius B, and what we're going to do is construct a circle of radius B, and radius B centered at point. It's centered at point A, isn't it? So the center circle is point A. Okay. Now, using your knowledge, what does that make? What does that make the point C using polar coordinates? What's the radius? B. What's the first coordinate? Cos or sine? So that's B cos A, and this one here? B sine A. Now the key to this question is always make one of the lines parallel to the x-axis. Because what will that make this coordinate here? C0. Is that alright? Now that we have that done, the only other weapon you need is the distance formula. What's the distance formula, lads, in coordinate geometry? D equals what? x2 minus x1 squared plus y2 minus y1 squared. Does it make a difference if this is x1, y1 and this one's x2, y2? What happens if Tom does it that way and I do it this way? Will it have any influence? No influence, okay? All those coordinate geometry questions, if they have x2 and y2 and x1 and y1, doesn't make a difference which one's which, right? And this is no different, okay? Now what am I going to do now, lads? So what's my next step using the coordinate geometry formula? So I'm just going to shrink this full thing. The diagram's preposterously big at the moment. Okay, so what we're going to use now, lads? So, what's the distance between the 2 points? Is it D or is it A? A, right? So A equals the square root of what, lads? Which one's x2 for me? B cos A minus x1. And then the other one, y2, b sine A, and then take away, square it out. Alright? So A equals the square root, and I'm going to multiply this out. So what's b cos A minus c multiplied by b cos A minus c? B cos squared A, yeah? And then what's the other part? BC cos A. Another BC cos A. So what's that? Am I happy to see that? Why? It's part of the cosine rule. And then c squared, is it? Okay, and over here? Okay. Out of interest, what'd be a good move here? If I squared both sides, wouldn't that be pretty amazing? So if I was feeling a bit lazy and I did this in pencil, what could I do? Huh? Yeah. Everybody cool with that? What's the goal? The goal is the cosine rule, isn't it? So what are you happy with so far? Yep. 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 What part am I unhappy with? Huh? I'm not happy with these two. Any suggestions? Once again, page 13 of your notes. Huh? Yeah, you can factorize out b squared, and you say that that's b squared cos squared A plus sine squared A. Can't you? Oh, I'll rearrange it to look better. And what can I say then? C squared. And then what else is it? Okay. And what happens here then? Huh? Down, it just turns into 1, and then we're left with what we're looking for, doesn't it? Right? Now, imagine for argument's sake, you're in the exam and you sort of choked, and it's in a different order. Okay? I think you'd all remember to do angle A, wouldn't you? Okay, you'd all remember to do angle A. For argument's sake, do you want me to do it with B even? With all the letters all messed up, and you can still see that you'll get a version of it and you can interchange at the end? Or would you be just... Alright, that's big. What's that? Small b. What side do you want to call this? We call it A, will we? Okay, well, that make that? Small a, exactly. It's all jumbled up now, isn't it? And what will this be? And what will that be then? Okay, right. Won't do that as formally, alright? What's step 1 again? Circle at point B, yeah? Circle at point B. Now if you can do it like this, you know it. Alright? I didn't learn that diagram off, did I? Brand new diagram. Now what can I say about this point here in polar coordinates? Yeah, it's radius C, so it's C cos B and C sine B. What can I say about this one here? If B is at 0, 0, so the centre of the circle B is at 0, 0. That's the one thing you have to learn off by heart. That wherever you put the middle, it's 0, 0. So what that make the point C then? What? That's A0, isn't it? And then what do you do next, lads? Yeah. Okay. X2, Y2, and X1, Y1. All right. I'm just gonna shrink this diagram all the way down. So essentially, I've learnt off sweet bugger all. I learnt the diagram. I learned that the centre has to be at 0, 0, and then I worked it from there. Okay, so what do we get? X2 is, so it's, what length are we getting this time? If we're using angle B, what's the length we're actually getting? Small b, isn't it? So small b equals what, lads? C cos b, take away a squared, and what? C sine b, take away. Okay. That's going to end up as b squared because we're going to square both sides, aren't we? Now multiply c cos b. Oh, the c's are hurting my eyes, but do c cos b minus a by c cos b minus a. Is that alright with you guys? What you get? C squared cos squared b, yeah? Minus. So stay here for a sec. And then plus a squared plus c squared. Lads, 1 second. What's cos squared b plus sine squared b? 1. So that's just your, it'll be a squared plus c squared minus 2ac cos b. And you can see that it comes out exactly correct. And if you got the wrong one, what could you say at the end? Interchange capital B with big A with big B, and small a with small b. Alright guys, that's us done for tonight. 2 sine rules and 2 cosine rules. Yes? We had to switch around at the end.